Moving on, in Module 12 of Physical Science, we'll be learning today about electrical currents. And besides learning about electrical currents, we'll be talking about conventional current and how the flow works in a battery. So electrical circuits have charges that flow through wires. And we'll actually be building an electrical circuit during one of our science experiments. This is an example of a very simple electric circuit. It's a battery hooked up to a light bulb. When the wires are attached at both ends of the batteries, the light bulb will begin to glow. So, electrical circuits have charges that flow through wires. The force between the charged particles can be used to make electrical circuits. And electrical devices use the energy from those charges to make things happen. And as an example, one of the things that could happen is a light bulb could begin to glow. A battery is an object that uses electromagnetic force. Batteries store electrical charges. One side of a battery contains chemicals that want to lose electrons, and that's considered to be the negative terminal. So if you didn't know this before, when you buy batteries, you'll see that the batteries usually have two colors, particularly if they're a cylindrical battery. And at one end, it'll have a negative sign, and the other end, it'll have a positive sign. This is the negative and positive terminal. At the negative terminal, the battery actually loses electrons, and they flow to the other side of the battery where it wants to gain electrons. When both sides of the battery are hooked together with a piece of metal, say a wire, electrons will flow through the metal from the negative side to the positive side. Batteries are rated by voltage. Most cylindrical batteries are rated at 1.5 volts. Small rectangular batteries with posts at the top are rated at 9 volts. A voltage rating tells how hard the electrons are being pushed through an electrical circuit. The higher the voltage, the harder the battery pushes electrons through the metal. Batteries produce the energy we use. You could probably think of half a dozen things right now that use batteries. Your car, your cell phone, electric toothbrush, you might have a watch, and similar items, a lot of them small electronics. The more voltage the battery has, the more energy the electrons have. The more that can be done with the energy. So the more electrons, the more energy output. The number of electrons is important, and the result is the amount of the energy available. Now, electrical current is the amount of charge that travels past a fixed point in an electrical circuit by each second. So electrical current is actually measured in amperes, or what we call amps for short. When working with an electrical current, you need to examine both amps and voltage, which we call volts, of the circuit. If either one of these items, either the amps or the volts, has a large amount, it can pack a good punch if touched. You don't ever want to touch the cables from your car battery. If the energy per electron is really large, just a few electrons carry a lot of energy. A circuit with low current but high voltage can be very harmful. Also, a circuit with low voltage can have an enormous number of electrons flowing through it. So the voltage would be low, but the current would be high. When a wire is connected to each side of a battery, it would look like the figure on the slide. So here we have a battery. It has its positive and negative terminals, and there's a wire connected to it, and this is a simple circuit. So it's very basic. It's not turning anything on. All it's doing is creating a current through this battery. Electrons will flow through the wire from the negative side to the positive side. Symbols have been developed to represent the major components of electrical circuits, and on an electrical drawing you might see a symbol like this. Batteries are symbolized with two parallel lines. So in a circuit, if you saw these two parallel lines, you'd know that there was a battery hooked up there. One of the lines is longer than the other. The longer line is positive and the shorter line is negative. And that is such a universal drawing that on most drawings that you would see, they won't even show the positive and negative signs. Now, conventional current describes the flow of electricity. And Benjamin Franklin, who was a well-respected scientist, originally described the current as proceeding from positive to negative. Later on, this was found to be erroneous. We found out that the currents actually flow from negative to positive. But because for so long it has been described as flowing from positive to negative, to this day you will still find drawings drawn as conventional current showing conventional flow notation, even though everyone who works in the industry knows that the drawings, that the flow will actually go from negative to positive. Interesting fact, the name battery was actually coined by Benjamin Franklin, and this came about because he had hooked up a series of multiple cells, and they reminded him of a battery of soldiers all lined up for battle. So that's where the name of the battery came from. The actual way that actual flow from electrical circuit and the actual way the drawing should look like would be from the negative post of the battery flowing to the positive post. And so this is actually how the drawing should look, going from negative to positive. So that's it for this piece of the module, and we'll be moving on to resistance, and we'll talk to you soon.